Welcome back to another exciting chemistry. In this lesson, we are going to look at another problem that deal with combustion analysis that deal with more than just carbon, hydrogen, or oxygen. Now we have nitrogen. So we have 1.2 gram sample. Okay, so we're missing our grams here. So we're missing our grams here of the compound containing carbon, hydrogen, nitrogen, oxygen. So we have 4 of them, okay? And as always, this will be the last mass that we had to find. Whenever you see oxygen right there, right away you need to think about, I have to convert everything to gram to solve that last. Now the sample is burned with excess oxygen, there you go. And it produced 2.2 grams of carbon dioxide. Is further analyzed and showed that the sample contains 0.06 gram of hydrogens. Oh look, that's easy. Okay, now part A, solve for carbon. So we have to solve the mass of each one of them at a time in order to solve oxygen last. Keep that in mind. So what do we have? 2.2 grams of CO2 converted to mole. By now, you should memorize the molar mass of carbon dioxide. Right. And then from there, we convert to moles of carbon. That's just 1-to-1 ratio. And then we convert to mass of carbon, 12.01 grams. Now, the problem with AP chemistry, whenever you see this, make sure you be generous with your sig fig, okay? Keep at least like 3 decimal places or 4 decimal places if your answer has it. But that way, because we're dealing with a small amount of substance, and you can see right, it's 0.06, that is a very small amount. So in this case, I plug in my calculator and I have 0.600. So you notice I have to keep at least 3 decimal places. And then let's continue and let's say, for in this case, it's further analyzed for nitrogen content and the mass percent of nitrogen. When everything percent, always convert to decimal first, and in this case, 28.8%. Well, that is equal to 0.288. Well, what's the sample? Percent is out of the sample. In this case, that's the one right here, right? So we have 0.288 times the total, which is 1.2. And again, you can see that if you plug in the calculator, you have this very small number, and it has at least 4 decimal places. So I'm going to keep 4 decimal places. So again, be generous with your decimal places because we're dealing with a very small amount. And then the mass of oxygen. So now we figured out this, the last part is oxygen, right? As always, we take the sample minus the total of what we already know. But carbon is 0.600. Again, be generous with your decimal number. And then we have what's next. Hydrogen is 0.06, and then followed by what? Nitrogen is 0.3456. Then we plug in the calculator. Oh, I forgot to put a minus sign there. Sorry about that. And then we plug in our calculator. What do we get? And it turned out to be 0.195 grams of oxygen. We have the mass for each one of them, right? And this is grams of carbon. This is a gram of nitrogen, and this is a gram of oxygen. Now the last step we have to do is, of course, convert them back to mole, and I'm going to use a different color from now on. So in this case, I'm going to start writing right here just to take space, okay? And of course, you already know how to convert to mole already. So 0.600 grams of carbon divided by 12.01. Notice how I just do it straight right there. And what do we have? And here we have 0.0499. And that is moles of carbon. And next one, what do we have on the list? We have hydrogen next, okay? So hydrogen is what? 0.06 gram of hydrogen divided by 1.008, okay? And that gives us what? In this case, we have 0.0595. And then followed by nitrogen. What do we have for nitrogen right there? So we have 0.345. 6 grams of nitrogen divided by 14.01, and that turned out to be, what does this turn out to be? We have 0.0247. Again, these are all mole. And lastly, what do we have? Oxygen, which we just found right here. So 1.95 grams of oxygen divided by 16.00, and that turned out to be 0.0121. And now which one's the lowest one? This is the lowest one. So now we can go in and get our mole ratio. So we're going to divide by the lowest one to get our mole ratio. And of course that turned out to be 1. That turned out to be what? This turned out to be 2.04, which is going to be 2, okay? And this turned out to be what? And then for hydrogen, this turned out to be 4.9, which we can estimate to 5. And then for this one, we have, again, 0.0121, and that turned out to be 4.1, which we can estimate to 4. So our empirical formula in that order, we have what is carbon? Carbon is C4. And what's next? Hydrogen. What's hydrogen? Hydrogen is, in this case, it is 5. And followed by nitrogen. Nitrogen is what? Is 2. And lastly for oxygen is just 1. And then, of course, you can, to get the from this empirical formula to the molecular formula, you have to find the molar mass of this. So we have 4 times 12.01 plus 5 times 0.101. Just keep that for now, okay? Then for nitrogen, we have 2.14.01. And lastly, we have oxygen 16. And let's do our math. And our molar mass turned out to be 97.07. And now we can divide it by this. So we have 194.00 divided by 97.07. Okay, let's do that. And this turned out to be 1.99, which is about 2. And this can be rounded to 2. So we multiply everything by 2. So 2 times C4H5N2O. And this turned out to be C8H10N4O2. And that is our molecular formula. So let's go in and check our answer. So I plug everything in, and I try to be nice to you by giving you a good range. And just for now, I just type into decimal place. So I'm going to submit and check, okay? And there you go. And that's how you solve this tremendously difficult combustion analysis problem. This is probably the hardest type of question that you ever get. So again, if you have a question about this problem still, feel free to copy your work and put it on the Google Drive, and then from there I will help you from there. And as always, never give up and do your best, and we'll see you next time on another lesson.